In this video, we will look at an induction question from the 2015 HSC, question 13, part C. This question deals with factorial notation, so let's go. Welcome to the first edition of Eureka Extension 1 Mathematics. Today we'll look at an induction question from the 2015 HSC paper, question 13c. Now with this induction question, it involves factorial notation. So before we begin, we need to have a look at factorials. So, the general expression for factorials is this. X factorial equals x times x minus 1 times x minus 2 times 3 times 2 times 1. Now, in a numerical sense, 3 factorial would equal 3 times 2 times 1, whereas 5 factorial will equal to 5 times 4 times 3 times 2 times 1. Now we also need to know how to factorize and condense these factorial notations. So the general expression is this. X factorial equals x times x minus 1 factorial. In a numerical sense, 7 factorial equals 7 times 6 factorial. 11 factorial equals 11 times 10 factorial. These are very important when we consider a question like this. Now, to begin, we need to first prove or test that n equals 1. So the first step. Test for n equals 1. Now, if this was n is greater than or equal to 2, then you test for n equals 2. Okay, so you just sub in n equals 1 into this side. So the left-hand side must equal the right-hand side. Left-hand side, 1 over 1 plus 1 factorial, which equals 1 over 2 factorial. I mean, that 2 factorial is 2 times 1. So that equals a half. Right-hand side, 1 minus 1 over 1 plus 1 factorial, which equals 1 minus 1 on 2 factorial, which equals 1 minus a half, which is a half. Therefore, left-hand side equals right-hand side. True statement. For n equals 1. Now the second step, we have to assume that n equals k. Assume true for n equals k. So we rewrite this series 1 over 2 factorial plus 2 over 3 factorial plus 3 over 4 factorial plus. Sub that into here, k over k plus 1 factorial equals 1 minus 1 over k plus 1 factorial. Now the next step is, and the most difficult step, is proving true for n equals k plus 1. Prove true n equals k plus 1. So I'm going to rewrite this series again and then add this on to the series. 1 over 2 factorial plus 2 on 3 factorial plus 3 on 4 factorial plus k on k plus 1 factorial plus k plus 1 goes into here. So k plus 1 over k plus 1 plus 1, which is k plus 2 factorial, equals 1 minus 1 on k plus 2 factorial. So now we need to prove that this left-hand side somehow equals the right-hand side. Okay, let's get rid of this. Okay, now I know that this series here is equal to that. So I can replace this with that. So 1 minus 1 over k plus 1 factorial plus k plus 1 over k plus 2 factorial. Now we'll just analyze the left-hand side. Okay, now with fractions we need a common denominator so we can add or subtract the numerator. Now k plus 2 factorial is just another way of writing k plus 2, k plus 1 factorial, if you remember from the beginning of the video. Now this is missing a k plus 2, and this is also missing a k plus 2, k plus 1 factorial. So we'll times the numerator by k plus 2 and the denominator by k plus 2, similarly with number 1. So times this by k plus 2 times k plus 2, and this one times k plus 2, k plus 1, and this is 1 times k plus 2, k plus 1 factorial. So now that we have common denominator, we can just add the numerators. So we have k plus 2, k plus 1 factorial minus k plus 2 plus k plus 1 over k plus 2, k plus 1 factorial. Now this k plus 2, k plus 1 factorial is pretty much k plus 2 factorial. So I'm going to rewrite this and put it into this term here, because that's what we want to find, that's what we want to get at the end of the day. So this will be just k plus 2 factorial, so k plus 2 factorial minus k minus 2 plus k plus 1 over k plus 2 factorial. Clean up the like terms. K plus 2 factorial minus k plus k is just cancels. Minus 2 plus 1 is minus 1 over k plus 2 factorial. Now what we need to do is just separate it, so split them up. So k plus 2 factorial over k plus 2 factorial minus 1 over k plus 2 factorial. So you get 1 minus 1 over k plus 2 factorial. And that equals our right hand side. Now, just going back a step, when we write what our left hand side is, always write from assumption. Because we gathered this part of the series from this assumption here. So we always have to mention from assumption. Now, therefore, left hand side equals right hand side due to proof by mathematical induction. And there's your 3 marks right there.